Does machine learning work? No. No, it doesn't. And that's very important. I know it sounds strange for a data scientist to be saying machine learning doesn't work, but what I'm doing is revealing a difference between the way models function and the way software works. It's a very important distinction because if you train your users to think of what they get out of a model as being exactly the same as what they get out of software, they're never going to trust what we build and they're not going to adopt it. So let me explain the difference between software and models. Software works. If you ask, say, an accounting software to find me all of my invoices for the month of June in 2021, I expect it to return all the invoices from that month. It should work. Now, the reason why it works without fail is because, well, it should, at least when I code it, it does. It's because we use logic to create software. It does this under these circumstances. And if the user follows the rules, then the user is going to get expected functionality out of software. It works. Models are different, and it's a fundamental difference. And it's the reason why, as a data scientist, we should not use models where logic will work. If we do, we set users up to expect something that works every time, and models don't. When you think about models, think about something like Alexa, a chatbot. There's no constraint on what you can ask Alexa. There's no constraint on how your voice has to sound in order to ask a question. There's no constraint on how old you are, how young you are. And you can already hear this is an intelligent process. A person can listen to any number of speakers. And even with a thick accent, we're usually pretty good at understanding what that person's saying. Alexa can do the same thing. I wouldn't be able to program in, logically, all of the code I would need in order to understand all the voices that Alexa understands. That's an important reason to go from I'm going to use software to I'm going to use models. But Alexa doesn't work all the time. I can, in exactly the same voice, in two different scenarios, try to ask Alexa a question, and it'll work one time and it won't work the other time. That's why I say models function. They don't work. We ask models to do things that software can't. Software, again, it's constrained to those logical processes where I can write out the steps in the software exactly as the program should behave, and that is sufficient for the use case. But you can see with something like Alexa and chatbots, that use case requires a far broader set of functionality, but there's a trade-off. It doesn't always work. It's functional. It's got significant utility. But at the same time, we have to accept as users that sometimes Alexa doesn't understand us the first time. We have to repeat ourselves. Sometimes Alexa gets a word in our question wrong or in our statement wrong. And we have to repeat ourselves. It's a trade-off. And we have, over time, using chatbots, been sort of trained as customers on the differences, on that expectation that we will get functionality, but Alexa doesn't work. It's not like software. But if we're willing to accept those minor problems, we get this amazing functionality from a model, like those that drive Alexa. I have the ability to ask a range of questions to Alexa, and the majority of them she can answer. If I tried to code the answers to every one of those questions, every possible question, again, just like voice recognition or voice to speech, trying to hard code the answer to every question, that's not something that we can do. And so again, this is another reason why we use models. But if I ask Alexa, hey, Where's the best place to get blue jelly beans? Am I going to get an answer? Maybe. And I have to accept that trade-off. I have to accept the fact that it may not work. So what's going on? Why doesn't machine learning work? Why do I say it's only functional? What about the process of creation causes functionality versus working? It's really when you look at the data, no data set for any complex task is ever going to be complete enough to handle every edge case, no matter how big the data set. And there is where machine learning models will always have shortcomings, at least for the foreseeable future. It's because our data sets are not everything. They do not encompass every possible scenario, no matter how good our architectures get. Until we make a fundamental breakthrough, we cannot generalize very well. And that's the flaw, is that we can't build models that do generalization across tasks, which in this case would be across all possible voices, all possible inflections, background noise scenarios, and all of those other edge cases. There's not enough data. And so the model itself trains into a set of functionality. And when that functionality has use, when the customer plays around with those early versions and goes, wow, this is really cool, that's when we release the product. What's very important for us as data scientists to take away from all of this is that we have to train customers. We can't just drop models in their laps because it looks like software to them. So they're going to expect it to work like software, and it doesn't. It functions. So we have to train our customers in the same way that time and usage really has trained us to understand how Alexa functions and to begin to play around. I mean, we ask Alexa some crazy questions, don't we? And she has some very interesting Easter eggs hidden, which is a lot of fun. That's the power of models. We can find and discover new functionality that we didn't know was there, and that allows us to use virtual assistants in ways that potentially the people who built those models never anticipated or intended. That's the cool thing about them. But the trade-off is that functionality versus working. So there's benefits, but we have to advertise the drawbacks in order for users to adopt and trust. I think that's the two most important pieces of making this differentiation. If users understand the difference between models and software, they'll understand and give it a little bit more leeway when oddball behavior happens because we've trained them, we've prepared them. And it's through that process that they'll begin to trust and begin to adopt more and more of these model-driven products.